And welcome. Thursday, yes. Welcome to Blade's world. Yeah, my world. Oh dear, it's my day off and I'm sat here doing this for you lot. That's lovely. What should we look at today? Yeah, I know what we'll look at. Got a couple of things I want to look at. So let's get ourselves one of these thingies. A computer, that might help. If anybody knows what that ship in the background is there, do you know what that ship is? Find out on Sunday. What do we got here? Ah, dear. Bless. Oh, we've got a computer that's off center. Alright. Let's do that with it then. It's a bit better. Except now you've got my chat messages in there. Okay, so we've got a computer loading up. And let's see what we're going to do. Ah, yes, I remember now. We need one of these things, don't we? That helps. Yes, it does. There we go. So, let's say hello to all. Hello to all. There we go, that's the chat started up so I can see it. Oh, that's a bit small, never mind. We'll have some fun with that, I guess. And yeah, what's all this lot down the left-hand side? So this is what I want to have a look at today. Different languages. I get asked about this quite a bit, and that is, how come I can write a program in any language I want? That's because I'm a programmer, or, well, a so-called programmer. I'm really a research and developer, which means I need to know about all of these languages and how to use them. It's as simple as that. That's my job. So how do you become that kind of programmer? Well, it's knowing how computers work. And that's what it's all about. So really, we're looking at assembly language, which is where I started. But mine was on a slightly more easier system, shall we say. Let's have a look at this. Let's have a look, see what I've got in here. Let's head over to code and have a look at assembler. Here we go. Switch this off now. Don't need that anymore. Yep, we've got Twitchy, as usual. I'll just close you. So notes is a file. Okay. So notes assembler. Here we go. This is what assembly language looks like. It's assembly. It's assembly language, and you use an assembler to run it because it assembles it. It's a straightforward language. You use system. You look up whatever chip you are programming. In this case, it's an 808. It's a times 86 chip, 64-bit. Or the times 64, that modern day one. This is how it looks. So as you can see, this one is setting up to define some bytes, which was said welcome to assembly language. 10, if I remember rightly, is the return carriage or next line or something in ASCII. So if you're going to write in assembly language, you'll need to have an ASCII table. You'll have to grab yourself a set of system calls. Good books out there on that, or you can just look them up on the web, it's easier. Set section data, section BSS, and section text. There's 3 sections. Your section data is your standard constants. All constant data goes in here. As you can see, you can message, you can tag it. That's a tag. So message, that's like giving it a variable name. Message equals define bytes, that lot. The length of message is equal to the beginning of this message, which is the $, which is there, minus message, which is there. And that will give you the length of the previous defined bytes in bytes. So that's a length, a way of getting the length automatically without having to worry about it. Otherwise, you can just set it to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9. 29, so that equals 29. You could just put 29 in there and it would work just as well. Variables, we haven't got any, and text is where you put your program code. Now that's the equivalent of saying, hey, we start here. So it's looking for that, and that tells it that we're going to start at that global marker there, I'll call it. So that sets up your program start. So it knows to start here with the program counter, and then it'll just move down through all of these and use your data as specified. So yeah, how it works is quite straightforward. You put your system call in, which in this case is a 4, system write. Standard output for the console is 1, so we'll pop that into another register. So that's the A register, the B register. In the C register, we'll put the message we want to output. And in the D register, we'll put the length of data. And then we just call to execute the command, which is ATH. Okay. That's basically it. So then we put in system exit, store the error code if there is one. No, there isn't one, so it's 0. And then call to execute the command. And that's all we have to do. We just have to then assemble it and link it. Straightforward, huh? Or was that too fast for you? Anything in chat? No? Okay, let's open a terminal. So we are using the NASM, which is... What does the N stand for? Is it a node or... It's network. So this is the network assembler that we're using. NASM. So if we put that in, and then we put in -f elf 64, which is for a 64-bit processor, which is what I'm using, and then you put in your notes.asm, -f, I think that's false. Can't remember what -f is. And that's all it does. NASM. What does that -f mean? Format. So that means format ELF64. Select an output format. Yeah. That's fine. So that will assemble to notes.o. I should have taken these off, shouldn't I? And then all you have to do is link. So you type in a link, which is a standard linker. that you get with any GCC or whatever. And that links it. And there you go. And then all you do is, let's have a look, notes. There you go, welcome to assembly language. It comes up. That's all there is to it. I mean, there's not really much I can say about that. Assembly language is pretty straightforward and easy. What I wouldn't do with assembly language is try and do like a 3D engine or something like that for putting stuff onto a screen, because that's a lot of system calls. What's it good for? Number crunching. What can we do with it? We can embed it into other programs. Most programs will have assembler ability to embedding, and that's what we're going to be talking about mainly today, which is embedding, I believe. So yeah, that's that. That's assembler. What else have we got? We have C, possibly my most favourite language of all time is C. Let's have a look at this one. I've got an A out already, haven't I? Yeah, we'll look at it. We just use code. You can use code for all of these. It really doesn't matter. Alright, so here we go. Welcome to the C programming language. That's how it looks. Doesn't that look like C++? Yes, except we have this. And that's from the standard C library. Looks familiar. So, what we do is GCC. Oh, that's familiar. Main C. There you go. That compiles it. And that's it. Really? Yeah, that's basically it. SFML works. Yes, it does. SFML is written in C. So you could actually write a 3D engine and renderer in C. Now that'd be an interesting topic to do. I didn't specify here what I wanted it to compile to, so it'll just do automatically to A out. So all you do is type in /a.out, and there you go. Welcome to the C programming language. Again, straightforward, simple stuff. The only thing you've got to watch out for with C programming is it's not object orientated. So if you want to add a function, you have to add upwards. So main has to be the last thing in the file chain, which is quite strange, but that's why includes always come first. At the top and not at the bottom, even though you can put them at the bottom. Yes, you can. You can put includes anywhere you want. It's just people put them at the top out of habit because of C. Because all like this is a preprocessor directive, so they see a pre-compiler directive, sorry, or preprocessor directive, depending on how you look at it. So that would be C. Not bad, simple enough. It looks very, very similar to what we've already done. So that's nothing new there. Close folder, please. Once it's staying open. So C's pretty easy. Let's have a look in the next one. C#. Often mistaken for Java. Let's have a look in here. Let's see what I've done with this one. Notes.txt even. So you have to start by doing a setup C# and F# views. Actually, that's F. That's a large F. What we're looking for here is .NET. Now, .NET is Microsoft's network, a framework for integration with networking. So that's why it's quite popular. It deals with the web, so people would use this in web. Again, it's interchangeable with other embeddable with other languages. So there's no problem with that. What does it look like? There we go. I'll put namespace in. So this is pretty standard stuff that you're seeing here that you've already probably seen, but now we're using system. And everything usually uses system because you need the system. That's because it runs from a system. It's not standalone. There is actually a server providing support here. And garbage collection and all that kind of thing is done for you. So you won't see any constructor-deconstructor pairs messing around. This is a straightforward write line. Welcome to C# and F#. Numbers. Calls static void numbers, which I don't like. For loads and loads of reasons. I don't like this format at all because it's hiding too much. It hides an awful lot from you. So does Java. It's the reason I don't like Java. Yeah, and it's just .NET Run to run it. So what's this? Yeah. Look at what's going on in here. So this is a Netcore application 2.2. This is all its debug information. That's what happens when you .NET Restore and .NET Run. It's going to provide a load of information so it can run it. And I want to talk about that as well. And under debug, yeah, you got all of that stuff. And it's just a load of stuff. Wow, that's a lot. Is there an actual... No, it's JSON. That's your debug information. There's your DLL. I think that's what it creates. I think it creates a DLL. If I remember rightly, yeah, it does. Yeah, okay. Okay. Assets, yeah. Alright, C#, we're in, so yeah. It puts everything in order. Okay. Because it has to run in a certain order. Can't display that one. Can't display that one. So it duplicates as well. Wow, this is bad. This is bad. So it's a language that hides too much. Let's try .NET Run. There you go. Finally runs it. So yeah. That big delay is caused by setting everything up. So this is going to be one of the slowest languages, slowest ones that you can find. Just like Java is. Unfortunately. Java's the same. Let's clear you. I can get rid of you. Close this lot down. Good God. I doubt I'll be doing much in C# or F#, but F# I wouldn't mind doing for a different reason altogether. It's functional. Whereas C#, yeah, is it still object orientated? Can be. F# certainly isn't. It's just functions. What else have we got next? C++, which you see me do most of the time. I haven't even written an example. Oh. Dot. New file. There we go, there's our new file. And what we're going to do, we're going to hash include, different set of includes for C++, but you can include all the C stuff as well. So C++ gives you all of C and then adds on top of it. That's the plus bit. So standard IO. As you notice, there's no .h. If there was to be a .h, it would be a .hpp for C++ instead of just .h. Int main. What is it now? argv star. Oh god, I can't remember it. I'm useless at remembering things. I'm very sorry about this. It's always the same with me. It's basically that line there that I'm after. It's the one that I write the least. Nah, ain't argsy. There we go. That's so you can add command line arguments. So you can type in things like if arg c is greater than 0, std no, I'll put it on the next line, we'll do it properly. So std cout, which is your console, and you just pipe it through, so it will be argv1. Will do. Yep, that'll do. And then we'll just do a standard end line. There we go. And then you can also use different bits and tricks and pieces and stuff like that. So you can do something like standard cout. You can put in something like return carriage or new line. Welcome to C++. And then I can put in a new line again at the end. And that's okay. Instead of putting in that part there, I've just put in a slash new line, so we can cheat, we can format within a string. Return. 0. That's the standard way of doing it, isn't it? Okay. Now, what happens here? Oh god, we can't include stdio. fix. I don't want a quick fix. I know where it is. I'm just wondering. Wait a minute. This is code, isn't it? Oh, God. Alright. Edit include path setting. User bin GCC, yeah, that's okay. Compiler arguments. Default include path. Oh, it doesn't have it in. Oh. I didn't know that. There we go. It will be /user USR. Better check actually. So it's user USR down the bottom. Oh, it finally came up with this. I was just about to configure JSON, but no, I think I want to configure this. User include. What we got in here? Are they all in here or not? Go down to the files. PQRS. Interesting. Do I have to go through to C++ or something? L. Oh, God. I've got GC. GDB. Come on, where are you? C++. 910. Are they all in here? It's got standard lib in here. stdexec. Where's stdio? I don't understand. How interesting. There's no just standard libraries. There's math. Map, memory, mutex. Yep, they're all here. Except for me standard. There's no other options, is there? No. Where do I usually put it to? That's a good question. Okay, we're in C++, aren't we? Hidden files, please. VS Code. Properties. Open with Kate, I'm not really bothered. Name Linux include path. I don't include it. Compiler path is the same, yeah. So what's it going on about? Ooh, this is a bit weird. Build, shell, build, GCC, yeah. I'm looking at what I normally configure it with. And I think it's because it hasn't got the build function in there. Huh. Linux. Include path. Oh, God. Let's now put my silly bit in, which it shouldn't do. Alright. Alright, so yeah, that's all it should have. That's really weird. Okay, I've got them all up here now. So normally I'd have defines, user bin GCC. Yeah, there are those 2 lines I want to add because they are usually a good idea. I'll put all 3 in. And that means I need a comma. Alright, so that should update everything to know where it's trying to look, I hope. Okay. I really don't understand why it's doing that to me. It's never done it before. It's not a .h, is it? Oh, don't tell me it's going to call me a liar and call it .h. Yeah? So I'm using the wrong one. That's why. There we go. Everything's happy now. Sorry, my bad. I was using the wrong include. That's all it was. So what do we have to do down here? Where's my terminal gone? Ah, there it is. What we'd have to do here is a GCC and a link, I think. I'm not sure, actually. I've never tried this. GCC. I'm going to do main.cpp. Let's try it. Yeah, you got to put that in as well, have you? Okay. Yeah, you have to put all the link stuff in here, don't you? Just want to make this the same as the other one, so. Okay. Well, that still accepts S. No, it won't. Problem with this is we have no make file. Yeah, because what you normally would do is do a make file with this. But at this point I also need the IO stream. As you can see here, it's just going to give me an absolute belly full of we can't do it because we don't know how to reference the basic out stream. The standard C out, it's undefined in function main, which is fantastic. I haven't written down my instruction set for it. Never mind. That's my own fault. Never mind. So clear that one. Okay, we haven't got that fully generating, but I'm not writing a make file. Not right now, I'm not anyway. That's okay, that's fine, that's fine. It's just explaining the differences in languages. So you can see now there's a massive difference in C++. You get all of this extra stuff, but you've got to do all of this extra stuff to get it to work. Yes. Can we close this, please? Had enough of that. That's why I use QMake, by the way. I don't use CMake, I use QMake. And I don't even think I've got it on this computer yet. Can we close down all this rubbish now? There we go. That's all closed down. I need a drink. So that's the kind of differences you're going to be looking at with C++. It's a bit more of a complicated setup. I would prefer to use QMake, and I bet I haven't got it. I can soon tell you if I have. F12. Enlarge so you can see what I'm doing here. QMake. Version. Oh, I do have it. Wow, I didn't know I had that. Really? Alright. Oh, it's Gareth. Oh, hiya. Hiya. I'm doing okay, me. Just relaxing on my day off. Showing you behind the scenes at what I do, which is I empty my head so that I know nothing. And then I try and do things that are a bit strange. Here we go, minus project. Puts QMake into project file generation mode. So I could do a QMake minus project. Should we try it? See if it'll do it. We'll try it in Twitchy. So that would be... Can I increase the size on this? Yes, I can. Here we go. I'll just put it down here. So QMake minus project. There we go. And twitchy.pro. Oh, you beaut. Wow, I didn't even know that happened. Okay, let's go back into code. See if we can do anything with a .pro file. Oh dear. This is an alternative to CMake. So all it's doing is app, twitchy, include path, sources, main, and that's about it really. Do I need to add anything here? Yes, I do. Qt minus equals Qt. No, I'm not putting anything in. Just going to use this template. Hash defines disabled, deprecated. Don't care. Input sources. Yeah, and then there's headers. And then there's libraries. Oh gosh, somebody's held a message. What was that about? Oh gosh, does that mean I have to go into the other mode? I'm on the wrong screen over here. So I'm just going to free your message up. I'm on the wrong screen on the other computer. My apologies. I mean, it doesn't give me the choice. Auto mod. Stop it. Oh, here we go. Allow. There we go. There you are. Yeah. Let's stop it doing that, shall we? Oh, build systems. Oh no, just use QMake. Oh gosh, if you've ever had problems with build systems on C++, visit Qt. I think it's IO, www.qt.io, and download their stuff and use their QMake. And don't show that again because it doesn't. Well, even if they move to CMake, there's still QMake knocking around in all the old files that they've got. I'm going to be using that. I think I've just downloaded it as straight on here by itself. I'm not sure. I'm sure I didn't put Qt on. Let's have a look. Is it a separate thing for me? No, doesn't look like it. So it's part of Qt Creator, which I haven't got either. So it's put it on my system using one of these other Qt things. Network. Why have I got that? Don't know. Got a couple of bits. Yeah, it's been dumped on my system by one of this lot. Somebody else is using it. It's pretty popular. I don't know why it isn't used more and more, because literally you just put what I put in, which is make me a project, and it does it. All I need to do now is create, say, a folder called build. Alright, and then just a new file. And I'll call it build.sh. In there I can just put cd build, so I'll keep it all out of my main directory. Then you would qmake ... one directory up, and then you just make. That's it. That's all you have to put. Put the two together and you get a very, very powerful thing. The only thing you've got to remember to do, which is not included in that, is change the properties on build.sh for permissions is executable. That's the only thing you've got to change that's outside of on the system. And now I should be able to do build.sh. There you go. cd build ls, and what we've made Twitchy. Twitchy. See how easy this is? I'll put an argument with it. This is an arg. There you go. How easy was that? Oh, right, questions are coming in here now. What are KDE and Qt like these days? KDE, I have no idea. I know I'm using it, but I've got no idea about it. It just looks nice, as far as I'm concerned. Qt these days is awesome. It's a lot better than it was, even a couple of versions ago. The improvements are massive now. It's stable, it works, it's a fantastic set of libraries. It beats the standard library hands down on all functionality. And I'll be honest with you, I would replace the standard library with Qt tomorrow if it was my choice. Gnome and Mate are too skinny for me. I like a bit more of a beefy type of operating system that can handle itself and look nice at the same time, which this one can. KD4 put me off. Okay. Reasonably quick. Okay, I push a button. I'm on a virtual machine, please note. This is a virtual machine running on Windows. They are not designed to be quick, are they, virtual machines? Yeah, it's quick. It'll work on anything. So, like opening Octopi. It's all there. It's all straight up. There's usually no problems with it. Wait a minute. Hold on a minute. I'm not actually using this the way you're thinking then. Just one moment, I'll back out of this. Let me just clear my screen up. So, get you back down. That was C++. We've looked at that. Close editor, close folder. Clean up, clean up. Right, this is KDE. Yes, you're quite right. But, then there's a big but here. So I am using Manjaro. And it says enjoy the simplicity. This is Manjaro. It's a free operating system using Arch. Oh, you also use Manjaro, right. Well, what you want to do then is press the Try Manjaro button. Well, I wouldn't use anything else. I wouldn't use Ubuntu. It's too damn slow. Here we go. Can we go down? Keep going down. Keep going. Here we go. This is it. Get Architect 18.10. All right, and you're going to suffer a horrible, horrible setup where it will bring you to this screen. You'll type in your username as Manjaro and your password as Manjaro. Then you'll type setup, okay, and it'll take you into a setup system. All right, well, try this, okay. Try Get Architect, because this one does all of them. All right, so you can choose what the heck you like. But whilst you're choosing what you like, choose KDE. But also, when it asks you what you want your shell to be, don't choose Bash. Choose ZSH. I'll show you why. Oh God, yes. Do it in a virtual box if you don't want to do the full machine. That's what I did. I'm running Windows. This is Windows 10. Doesn't it look good for Windows 10? Doesn't it work well for Windows 10? Oh, you already use it, so you don't need me to tell you what it's all about. ZSH is a damn sight better. Let me just open it up and I'll show you what I mean. It also runs Node.js, and this is why you need ZSH. If you're going to be using Node.js, which is my next topic, you come down here, we'll have a ZS. We'll have a Z one, won't we? No, we won't. Which one is it? Cache config. Oh, I can't even remember. Should be able to remember these things by now. Ah. I've got an npm rc. Here we go. This is it. ZSHRC. Open that file. It's .zshrc. This file has... Oh, God, that's small. .zshrc. Here we go. That's the one I want. Right, this is the file. Okay, you get this beautiful file. Yeah, right, okay, get lost. Microsoft. So, what it tries to do, it's got autocorrect mistakes on it as well. Gareth Hubble. Dual boot. No, I don't use dual boot. I've been asked not to. The boss forbid me to do that anymore. Took it off. I was using up too much of his hard drive. Fish is a nice shell, but environment variables are odd in that. No, I don't want odd stuff. This is fantastic. It's straightforward. For instance, I have here additions to system path. I have an export path for my npm global Now what does that do? That means that my global only affects this instance, my username, rather than the whole goddamn virtual box. So if I want to use my virtual box again as a different user and do something completely different with it, going down a different path with something different, different project, for instance, that could already be on here. I don't want this stuff accessible. I don't want all of this stuff accessible. It has to be separate. Plus, if somebody now breaks in, because I do this on as a stream, if somebody breaks into this, they're only going to mess up this. So if anybody wants to hack me, you can do so. I'm not bothered. You can do what you want to this. This also shows you very easily how you can do your key bindings and aliases and everything. It's fantastic. So ZSH for the win. Make sure you got your ZSHRC, and if you're going to be using Node.js, which I'm going to cover next, put your export path in and change Node.js defaults to use this path, to use ZSH instead of .bash. That's the only thing I can think of there. Get rid of hidden files now because it upsets code. Okay, Gareth Hubbell, it's my personal machine, so I can do as I like. You lucky person. Now, this is a nice i7 machine that doesn't have a fan in it. Think about that. I'm running an i7 chipset with graphics card with no fans. Don't tell me how it was done. I might take a picture of it one day and show you. Right, Node.js. What have we got in Node.js? This was the topic of interest last time, so I think I might leave it to last now, because I've altered everything so much. Python. Python's a good language, good starting language if you don't want to program, maybe. Yeah, okay. Let's have a look at Python, shall we? Let's have a look at my notes. There you go. Command line. Yeah. First thing you want to do is which Python 3. Why do you want to do this? To find out that if you're using Python or not. Okay. On Linux, you can change modifiers to, if you remember, had to alter the permissions on that .sh file. Well, there's your command line way of doing it. Change files to executable. And then all you do is / whatever your script is, pi. And it becomes runnable. And if you type in Python 3, it goes into interactive mode. So this is very easy scripting, Python. Very easy scripting. So what does MyPy do? That. I told it at the top to bash, or .zsh in this case, Python 3. And then just to do that, so all we do is type in /my.py for Python. Oops. What did I do wrong? Yeah. So correct, yes. There you go. Welcome to Python. See, it even corrects me when I do spelling mistakes. So that's Python. Straightforward language. It's used for scripts. Wish I had a personal machine like that. My personal machine is solid Linux and was built using just the KDE version of Manjaro. So it's rather nice. It's very nice. It's what I use to watch the stream, and I've got it all set up wrong at the moment. That should be there. That should be there. That should be there. That should be closed. I should be able to see chat properly on this screen now. Video previews over there as well. There we go. So that's Python. That was a simple one. Python is very simple. That's the whole point of it, I suppose. Can do quite good stuff actually in Python. if you want to use your machine in different ways, then feel free. Use Python type of thing. It's rather good. File. Close folder. Get rid of that. So yeah, Python's easy. Any languages you want me to use? I don't know if I'm going to be... I wouldn't use code for this, would I? Java. What do I know about Java? Quite a bit. Yeah, there you go. That's all I'm going to say. If you're going to use Java, use IntelliIDEA for Java. Don't use code. I think that's the easiest way of putting it. And the one I've missed out. I've got IDEA on here. Yeah, so use this one. And IDEA is a long loader. There we go, IntelliJ IDEA. Nice and easy. Have I ever used Haskell? No. Do I know how to use it? Well, yeah. Would I ever use it for anything? No, because I can't think of a usage outside of these lot. So yeah, just create a new project there. You just create a new project and off you go. No, don't do it. I don't want one. I've already got one on Saturdays. I'll do Java on Saturday for you. Haskell. Let's have a look. I haven't got it loaded. Okay, we've got Emacs Haskell mode. Anything you would download for better errors. Oh, well, that's exactly what you want, isn't it? So what's this? High performance. You joking me? Haskell high performance. Where did that come from? It looks like a modular language to me, Haskell. So, is this a derivative of Python by any chance, or Node? These look like includes. This is starting to look a bit weird. Oh, Chobo Cannon, yes. Hello there, shout out, mate. Okay. So let's have a look. Can I actually do anything with Haskell? Probably. Let's have a look at it. This is where this is how I do research and development, by the way. This is my job. Oh, statically typed, purely functional. Yeah, that's Python. Sorry, I don't mean to be nasty. I'm just being silly. So, let's see, 1 to 1.4. 2016, yeah. Code examples are module main, where, main ID, main, right. So, start off with a main. Factorial n, yes it is. It's modular, it's C gone wrong. Yeah. And those have a completely different meaning in Haskell, don't they? Right, okay. Implementation. It has a GHC compiler. Intermediate language is C minus minus. Well, never mind. Libraries bindings to OpenGL. So, right. Yeah. What's the Haskell platform? Yeah, it's not object-orientated at all. C++ is. C isn't, it's functional. functional determinations. Or functional declarative, should I say. Facebook, right. Testbed 4, advanced functional programming features and optimization in other programming languages. That's why I don't use it. Yeah, I remember now what it is. Yes, it's brilliant for testing other things. It's a logical wizard. Yeah. N plus K patterns, yeah. I remember it now. Would I use it? No. Because I would test my programs as I went. That's the simplest way that I can put it. I would not ever write in such a way that I would need to use Haskell to determine whether a new kind of functionality placed into a program would be worth it or not. I would decide that up front whether a functionality placed into a program was worth it or not, and if I wanted it, I would test the implementation of it as I wrote it. So I would use test-driven development over Haskell. If you want me to do something in Haskell, I can add it. But I would need like a project for it to really add it. I haven't got any. Yeah. Yeah, I mean, most code has a purpose within the programming industry. Like Node.js is for server-side programming. Well, it isn't really, but it is. That's where it started. It's now gone into advanced web development. Advanced web development now uses Node.js. C++ now embeds Node.js. That's a good point. What was I looking at? I was looking at something. Right. Can't see it now. God damn it. I was doing some research on it the other day. Oh, wait a minute. Let me just finish off the talk through. Yeah, we haven't done Node.js. Right. Why did I want ZSH? And why did I want to alter that line and ask Node.js to use it as my global rather than anything else? It's because of what happens when you make something. So let's go back into code. Dot. Get rid of this now. Right, we can use the command live server. So, first of all, I've got to explain what I've done. I think that's going to be the easiest way of doing this. Have we got them? Yes, we have. So, what we got here? It's cleaned up everything. Before, I didn't have this. Whereas now I do, I have libraries, which is better. I can handle libraries better when I'm developing. So as you can see, I've got P5 in here, and this is a P5 startup. So what I did was I did npm, npm P5 manager. That's a thing. So search, I'll just put it that way, P5 manager. So yeah, there you go, P5 manager. That's the template that I've got here. So P5 manager made that for me, which was very nice of it because it makes it easy to use. But what I can now do is I can start up the live server down here, because I've also npm globally installed the live server. Would I find Haskell interesting? Yeah, I find all programming languages interesting. I find programming overall. I'm addicted. I'm an addict. I'll program in anything. So I did npm install live server. So if I type in live server here, there we go. There's our live server. It's blue. Why is it blue? Because it's running this HTML here, which has the source in for the P5, which has that sketch in saying blue. Why would I use this system? Because I can do that. So if I put 200 there and I save it, there you go. It changes to purple. So I can see the web page and I can develop it. I can draw on it. I can set it up using Node.js, doing all the normal things you can do with Node.js, and I can see it all at the same time. So that's a rather good system, I think, for programming, if you want to start up looking at Node.js. So all you really need is the live server. You might want the HTTP server as well. There is one of those. I think I downloaded it. Think I did. Where would it have put it? I can't remember now. But it puts it inside another file so I can look it up. Yeah, so that's Node.js. Nothing to it. It runs as you write it. You can do it that way, or you can run it separate to how you write it. It's your choice. To run it separately, how do you get out of this? Is it Z or X? Oh, that'll do. Don't care. So I could do npm start. There we go. There's no error. Sorry, it's full of errors because we haven't got a JSON file. So I haven't even set up that. Let's see. What's the other one? Can you do node? I mean, find out what's in here first. Sketch, isn't it? Where's the index? You just do node start, node run, and it'll say error because I've done it in P5. Never mind. P5 run. Oh no, it's P5 generate. Oh, this is a nice one. That was P5 generate bundle twitchy, and you just start. It's server side, so you can just use servers for that. You can use a HTTP one. So that's interesting. What else can you do with Node? Where am I? I'm in Node.js twitchy. So I could go cd ... make a directory and go into it and just install a normal node, and I can show you what happens there. It just looks like a mess when I do it, so I'm not going to do it. I have always delete it at the end of the day. But that's Node.js in a very easy setup using P5 Manager. Look it up. It's got a home. So if you go to npm, that's the one, npm.js, and you put in P5 Manager. There it is. Click on it, and it tells you exactly what you need to do. There you go. That's all I typed in there. npm install -g P5 Manager. You can have collections. We can put collections together. It's a rather pretty nice system, really. And it'll do bundles, split view modes. So yeah, it does pretty things as well. It's a graphics library for web pages, but you can stick normal Node stuff in there as well. Yeah. So if you want to play around with Node, I would say that that's a good place to start. What was I looking at before? I was looking at embedding it. Okay. Add-ons. C++ code from Node, but no, I want to do it the other way around. C++ add-ons documentation. Written in C++, that can be loaded into Node.js. Alright, fair enough. You can load C++ into Node.js. There you go. If you really want to. It's not on this page. Where's my next page gone to? Yeah, there we go. That's what I was looking at. So duct tape is an embedded JavaScript engine with a focus on portability and compact footprint, and you can put it inside C++ by using a ducttape.h. Yeah. So yeah, any of you out there using Node.js and you want to get into the field of C++, there's duct tape. Quite happily man. Don't believe how they spelled it. Is it available to me? Duck. Yeah, it's available to me. So, embeddable JavaScript engine. There is also duck.py, Python bindings for the duct tape embeddable JavaScript engine. So you can put JavaScript into your Python. Python 2 to duck.py. Yeah, there's lots of ways that you can use languages. You can embed them, you can do whatever you want with them. Doesn't really matter. So, if anybody has got a project or wants me to explain more in any of these languages, I'm quite happy to do so. I'm currently doing an ECS script or ECS program for C++. But it's got rather complicated, so I'm not sure that anybody was going to view it or not. That's what I've been currently streaming. But once I've got the ECS system out of the way, it'll slide in with the keyboard handler that I wrote last week. So that's going to be good. That's what I'm doing on the Monday, Wednesday, Fridays. Does anybody want anything else? I mean, I'm open to anything you lot want to see happen. I was asked about. Went through all of that Electron stuff, didn't I? That you can put Node.js into Electron and bring it out of the web. Did that last week. Out of the web server and into a window on your desktop. So I've done all of that. I'm just wondering whether to go backwards into C programming because it's easy. Is wondering because C is a beautifully written language. It has 15 main commands. 15. The whole concept of C was based around 15 commands. And yet you can control a whole computer with it. where the basis of assembly is the chip and what the chip can do. C is what you can do with 15 commands. That reminds me, I want to tell you a story. Okay, well, let me get some Coke. Oh, sorry, some black, bubbly, burpy liquid. This has reminded me of what somebody did in assembly language. Very, very close to my heart. There's something called a Turing complete function. Now, Turing built all of his computers using transistors, literally, or gates. So that there was this weird thing that if you took one of his systems and set it up so that the inputs were a function, the answer could be reversed back through the gates to give the function. So Turing complete means you can compute both ways. A function can give you an answer, and the answer can give you the function. And that's a Turing complete thing. I'll call it a thing. And what they found out in assembly language was that the move command, I'll actually just pop it up a second. Code. Stick a code up. There we go. That'll do. I'll just pop it over the top. So this move command here, MOV, is Turing complete. So if you move some value into that address and execute it, you can, by what the system does or performs, you can reverse it and know what was moved into A register, into the A register and the B register. So the move, and you can actually reverse these messages as well because the messages are here. So you can reverse engineer everything in that. All of this is totally reverse engineerable. That's what they call it. So that's that block of code there is completely reverse engineerable. And they actually made a compiler which would compile any C++ program into move commands. And they actually made a move compiler, and it worked. So the only thing it outputted was move data around in memory. And they compiled a whole program that could do it, just with move. That, to me, is just awesome. That is, to me, what it's all about. Somebody having a stupid idea like that. Oh, wait a minute, this is Turing complete. So I can compile everything into moves. In other words, one command is all you need to run a program of any type. That is astonishing. But it's absolutely provable and true. Look it up on the internet, I'm sure. You just look up the move compiler, assembly move compiler or whatever, C++. C programming, how does this go? It's not like C++. What you don't do in C is make a load of files, because by doing that you're just wasting your time. Every function in C is primarily like this first one. So there's no class I'm aware of. No, class doesn't exactly work. I think I'll find it hard to stick to C actually if I do start typing it right now. Let's see if we've got the command words for it. There's only a few of them. C. Programming language. Wiki. Okay. ANSI C. C18 exists. Oh, it's got a macro now for standard C version. Is that it? It's just technical corrections. Well, you can't really correct C. There's nothing there to correct. Reserved words. Right. Yeah, I thought so. There's no class in there, is there? So, yeah. Closest we've got is struct, I think. Yeah, struct. We've got that one. And that's it. We can have structs. C18. Well, to me, this is C. This here. That's all you've got. All of these are just reserved. 5 more reserved words for imaginary, inline, and restrict. C11 reserved 7 more words. Atomic, generic. There's nothing there that you need to use. It's just adding threading, isn't it? Yeah. So that's all. Just added threading over the years. But your computer does the threading anyway these days. There's your hello world, yeah. Pointers. Really? C supports pointers? Well, yeah. Oh, sorry. Yeah, let's have a look at C18 link. Somebody wants to look at the C18 link. Let's have a look. Syntax hasn't changed much. That one. Changes. Standard version, that's it. Bug fix release. So, yeah. Compiler supports GCC, yeah. I mean, there's nothing to C. Most C language stuff usually rides in a single file if you're going to start using it. But GCC, yeah, just use Linux. If you're going to be programming, you're probably on Linux. Let's be honest. So GCC. You can use GCC on Windows as well. I do try to use Visual Studio 2019 on Windows nowadays, but as people have realised it's crashing, it doesn't work. So I've stopped using it for a bit and gone back to Linux. So I'm doing my C++ work on Linux at the moment. I only do it on Windows because people want me to do it on Windows. My preferred is GCC on Linux. It's just so simple. It's ridiculously simple. Clang is a bit more common. Yes, I started off using Clang, I must admit. Then when I realised it's just simpler to use GCC because it was native, I did that. SFML. Let's go to that website. Right, SFML is a lovely little thingy. This plugs you into like 3D. Network. I haven't done networking with it yet. That could be interesting. You see what they've done here? I'm not sure that's C. I've got a problem with that already. Yeah, there's context on that as well. Yeah, this can be done. Except I'm not using std cout because that doesn't exist. This looks like CPP, yeah. It is. Oh, OpenGL HPP. SFML does work. Oh, I'm in the wrong directory. That's all HPP. Wonder why it says SFML works in C then. That's interesting. Multi-platform, yeah. There you go. C. C++, C, Java, .NET, Python, Ruby. So they've included it. There you go. Official bindings for the C and .NET. That's why. Okay, C. CS. Aha. I need CSFML. See if I've got it available. Yes, I have. There you go. There it is. And that's how I work. C bindings for SML. So I can now use SFML in C. Wow. Tick that. Yeah. Let's just put in a code. What was it anyway? I don't know. One of them, I think. Well, that worked. There you are. Done. We have it. Where did my window go? Ah, sorry, not in this window. That's why. Oops. I'm using this on Windows and I've got a different computer. Authors, yeah. Oh, there you go, Haskell as well. Bet you didn't know that. Ruby Rust. Oh, Rust. I haven't included Rust. Oh. Rust programming. Oh. Let's design our own systems. Yeah. Well done. Well done there, Chobokanin. I think it is. Chobokanin. Rust would be interesting. No, Rust would be very, very interesting. That's a learning curve. Rust is harsh. There's two sides. For starters, there's two sides to the language. There's a safe and non-safe side of it. Ruby wouldn't touch with Bargepole. Ruby on Rails, PHP, all of that stuff. I can hack that stuff in 5 minutes. No, not touching it. Did I tell you I was a research and developer? No. Node.js stands a chance against me. Python doesn't, really, but it's script only. I'm more likely to use it than I am to break it. C++ is the hardest one to break because it's really weirdly programmed. But that's about all, especially the way I'm programming it at the moment. Template programming on C++ is what I'm doing right now. That is interesting. I didn't know that. Oh, Camel, forget it. Nim, never heard of it. Good. There's one I haven't heard one of. Julia, yeah, Java. Is Nim just a side shooter C? Right, okay. You can tell what things are by what they use. Go. Right, okay. Does that say, is that, if you change that to an A there in the middle, I think that'd be fine. I don't know why people are using Go. Again, isn't that towards web rubbish? It's not the web that's a problem, it's this that's a problem. .net. The biggest problem that I find about the internet and people's programs and websites when they're being hacked is that their .net framework or their web PHP framework is dodgy. Get rid of this. Don't fancy doing any. I'm not working today, so I'm not doing that code. But yeah, it does. But that's a C in front of it. Now it's correct, you see. Just get out of here. Just go into here, put up code here. Alright. What I'm talking about now is this bit. The actual web page. I don't need to see that. This is what constitutes your web page. Can you see any problems with it? If I go onto this web page, what happens if one of these has been missed or one of these has been missed? If you watch this, I can make all of these left angle brackets disappear. There you go, all the left angle brackets are now in this darker colour. Oh, they've gone light now, have they? For this, oh, it's highlighted it differently because it's bloody HTML. You skunk. In C++, I can't see them at all. They go dark, dark, dark blue. But it's too easy to miss one. And if you miss one, you've then got dangling scripts, dangling styles, dangling body parts and everything. So you've got to be very, very, very careful about how you use stuff and what programming language you use to do stuff with. At the end of the day, this index HTML is the first thing that a website will run on its page. That's what it looks for. That's how it's designed. That's how the server's designed. So this page has to be there. And as soon as you know that, you can poke and prod around that page and find vulnerabilities in that page, which the user of it doesn't even know's there. How do you compile and verify that that script is correct? You don't compile it. You don't. All you can do is look at it. You've got nothing, no mechanical way of going through that script. You'd need a HTML parser. Have we got one? Good question. Actually, I can leave that up. Do we have a HTML parser? To make sure that I write my HTML correctly. Simple HTML and XHTML parser, Python 3. Python 3. You little bless, you've got one, have you? So you need to get one of these. Java's got one. So you could check it using Java. We can't seem to check it using JS, which I think is weird. I wonder, is there a JavaScript parser for HTML so you can check your own HTML before you run. Now there's an interesting thing. So all of those people out there using Node.js, how do you check your HTML, please? I'd love to know, because when I've been poking and looking at other people's HTML code, the amount of errors I find in them is absolutely yikesy astonishing. It's at least 1 to 2 errors per page, and I've got a page up which does hardly anything. That's just sick. Python. Extract information from live website. No, I don't want to do that. I want to check it before it goes live. Parse HTML using Python. Beautiful SOAP library. Oh, God. That's a class for what? Double quotes, that could be C++. It's worrying? No, it doesn't worry me. It should worry the people who have websites. It doesn't worry me. I'm on the other side of the fence. I don't care. You want to make mistakes and make it my job easy, that's up to you lot. But yeah, if you're going on the web and you are using something like Node.js, learn Python or Java, so you can pass your HTML to your heart's content to check that it's correct. Ah, dear. Yes, the self-retweeting tweet is very easy to do. Very easy to do. Is it who does tweets? I'm not into this social rubbish because it's too unsafe. Who does tweets? Is it? It's not Twitch does tweets, is it? No. Twitter, that's it. Oh, that's why I couldn't remember it, because there's no A there after the W. Yes, Twitter. That's the one. Yeah, I don't call it that. Log into your Twitter account and find out. Dare I even go near that website? I've never been to it. No, directly anyway. Follow your interests here, blah, 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 blah. About, help center, blog, status, jobs, terms, blah, 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 ads, info, brand, apps. Developers. Apps sounds interesting. What you got in here? Yeah, right, company. Okay, just advertising your own product. Explore Twitter. Okay, that doesn't really give me much, does it? Documentation. Account activity API. Here's your API for Twitter. Do you feel safe? Feature summaries, yeah. Next steps. Apply for access to get started with webhooks. Do you really feel safe? What do I want an account for? API references to find the right endpoint for the job. Check out our API references. Okay. Subscribe to account activity. I think, here we go. Returns account of current active subscriptions. I can get subscriptions account. Here's the API for Twitter. It's about as safe as a sieve. Look at it. I've got delete here. Delete subscriptions. Delete subscriptions all. That's safe. Oh God. Do you know how to access this? Do you know how to access this API? It says at the top. Developer.twitter.com. English docs. Accounts and users. So what? What's OAuth? It's unauthorization standard, which means nothing. This page cites feck off. Was this document helpful? Oh well, I'm not going to tell you if it was helpful to me or not, because I'm not allowed to say. But yes, isn't it nice that they advertise that you can delete all subscriptions remotely? And yes, it does use OAuth, you're quite right. This is the problem. It's the same with Google, YouTube, Twitch, all of them. You can read the APIs. AUTH. It's KAuth. There's no OAuth in here. Oh yes, there is. There it is. C library implementing OAuth. Shall we have a look at the header files and see what it's all about? Do you think you're safe? I can download it. And I can use it if I wanted to, or just bypass it if I wanted to. Do you think the internet is safe? No. Why isn't there any hacking going on those accounts right now? Why aren't they all being hacked and deleted? The simple answer is because it achieves nothing. What does a hacker have to gain by going and hacking into somebody's account when all they need to do is look at what they say? It's pointless. I wouldn't hack into Twitter if you paid me to. Because it just isn't worth it. I mean, if you had a grudge against Twitter, then yeah, they've made it slightly easy for you. But you've got to be careful with your private information. Don't feel safe on Twitter, YouTube, or anywhere else. Don't feel safe at all. It's why I say, if you want to hack me right now whilst I'm streaming, you can. I don't really care, because the only thing you're going to do is delete this Oracle VM virtual box. I don't care. But social networks and stuff like that, I definitely don't use. The only things I use are Twitch and YouTube, but obviously for videos. I stream on Twitch and I save all my videos up to YouTube, because Twitch doesn't save your videos. Yeah. So let's see if I can find myself on YouTube. I always do it as one, don't I? Because I'm an idiot. That's it. Here we go, youtube.com. It's asking me to sign in. No, thank you. Amberskies. Ooh, I'm top. Wow, I actually got to top at long last. How did that happen? People must like programming. Because I'm not doing much in the XCOM games. Oh, God, yes. XCOM. This is where they're all stored, by the way. All the videos and everything. So that's Amberskies. So that was easy to find. Interesting. Yeah, did anybody notice? I've got a ship here. Don't know if anybody's noticed. I don't know if any of my Sunday Sunday viewers come and watch any of this, because, yeah, I bought a new ship for Sunday. It's going to be ace. It's a fantastic little ship. What else have we got here I can think of? Sorry, no, Twitch has me videos. Vids, I call them videos. Twitch has my streams. It only saves them for about 2 weeks. So on Twitch you can't really get much. Except for 2 weeks worth. Doesn't save them. I'm not an affiliate or a member or whatever it is. I don't have enough people. I've got 47 followers according to this, so I don't have the 50 required to even apply. Oh well, what a shame. I don't mind. I don't want to make any money out of this. That would cause me more problems than I want. So it's not a money issue. For me, it's just getting code out to the world and showing you what's safe and what isn't safe, and how I do my research. It's not hard to find things on the internet which you can tunnel through. Node.js actually would work to attach yourself to something like Twitter. But you'd have to generate a key pair for the authorization. So I would need an account, so I'm not doing it. I could set up a false account, I suppose. But that doesn't sound good, streaming that kind of thing. I don't think I want to show people. Well, I could do it in a positive way. Show people how they could access their own accounts without actually logging on to Twitter. Could do it that way round. If I do the YouTube one, I would break my own YouTube. Because the keys would be shown on stream. Yeah, can't do it. So, any questions? Anything anybody wants to know about any of the languages I've got down the left? I'm not adding Haskell, but I think I am going to add Rust. Should I add Rust? Really could take, well, Python seems to be the glue at the top. C is the glue at the bottom. Assembler language. Would I do Rust or assembler? I prefer assembler. X64. It's not instruction set, is it? CPU. See what that one gives us. Oh, it does give us the architecture. That's good news. That's handy. Common flags. Floating point types. Oh god, MMX. SSE3. Yeah. Tools. NASM, I'm already using. YASM, and then there's a flat assembly. They don't seem to be as useful. And your linker is just your C++ linker LD, so that's alright. Nothing in there. Operation codes. That's about it. Push, pop, add, subtract, multiply, divide, move. That's about it. C move. Conditional. Okay, shifting left and right is how you usually normally do things, and XORs. Yeah. On the opcode, right. Where do I get a list of operating system codes? Well, this is a great one. Does it have anything under docs? Dunno. Don't want them. I've already got them. So there's nothing there. Let's have a look. Intel 64. Software Developer Manuals, HTML. Combined volumes. Alright, you gotta buy it. It's just books. Just books. Oh well. So I need a list. It'll be on the internet somewhere, it's just finding it. So it's going to be the Intel Architecture x64 is what I would need. Cancel, thank you. Oh dear. Might be able to put that in direct. Intel Architecture x64 op code list. Software Developers Manual. So it's got the PDF. Come on, where's the operating codes? Chapter 2. Oh God. How big is this book? Oh, well, it's got up to E on the index. Appendix, sorry. So we've got a chance. Oh, God. D. Input, output, yeah. So it looks as though you just got to go through the book. God. That's a lot of reading. I know how input-output ports work, thank you. I was around when I was still alive when they were designing them, thanks. I went to the factory and had a look. So that's no good to me. Yeah. Thoughts. Oh! I got a Prezi this week. You'll never guess what it was. It was a gift. Oh, it's updating Steam. Come on, show the gift. Show everybody in the world what I was given. I'm a big nutsy fan of a certain type of game. As you may have already worked out, I play a lot of XCOM 2 in my spare time because it's mouse only, which means I don't need to type, and my hands are doing a lot better because of that. I'm able to type here on stream type of thing. Look at this. Can it shift? Can it move? Can you see what it is? There. Well, just above it is Enemy Within. Yes, folks, I have been given XCOM Enemy Within with XCOM Enemy Unknown. And guess what the first thing I did? I downloaded Long War because it's my favourite mod for the game. And I did a test run on, like, I failed the first mission twice before I succeeded it, put it that way. It's awesome and it's scary as hell. It really is good. So I might do that later. Actually, I could do a stream of that today. What are we on? Nearly 4 o'clock, so we're coming to the end of this stream, aren't we? Yeah. We've got 3 minutes left on this stream anyway, if you need me for anything. Otherwise, I think I'm going to wind down now. I've been through all of the languages, and I hope people realise now that you can embed any one of those languages in any other language, so you can use multiple languages for things. That's good to know. You can use a server in the middle. You use one language on one side and one language on the other side of the server communicating, with a server communicating between the two, which is roughly how they do it anyway when they're embedding like things like Node.js into C++. It'll work with C# and F#. I should put F# there as well, shouldn't I? And C, yeah, it'll work with C. Assembler code can be literally dumped into anything, I believe, as long as you just call the function the right way and assemble it as a function and not a actual program. Yeah, it'll work. Can't see why not. But that's roughly about it, I think. So unless there's any more questions, I'll do the outro music and let you people relax.